Okay, welcome back. We're going to talk about solving quadratic equations using the square root property this time. So this extends our ability to solve certain kinds of problems that we might not have been able to solve previously. Now, in chapter 8, we had assumed that when we were taking the square root of x squared, that x was positive. But if we don't have the restriction that x has to be a non-negative number, then it is potentially possible that when we take the square root of x squared, we need to get a positive value out. Remember that this symbol requires us to get a principal square root. So the principal square root of x squared over the set of real numbers is defined to be the absolute value of x. Well, let's look at what this practically means in terms of this expression right here. Let's say we've got x squared minus 16 is equal to 0, and we're asked to solve for x. Well, we can use something called a square root property. And in a square root property, the way it works is that we could say if we isolate x squared to the left-hand side by setting it equal to 16, then when we take the square root on both sides to isolate x, the square root of x squared equals the square root of 16, it's like we're saying from above the absolute value of x is equal to the square root of 16, which is 4. And if we recognize that the absolute value of x is one of those equations where we had to get two solutions, we're going to get x is equal to the negative of 4, because the negative 4 when squared gives us positive 16, and x equals positive 4 as another solution. Now, typically what this means is that we just use a shortcut and say that if x squared is equal to 16, then x must be equal to plus or minus the square root of 16, which is, say, plus or minus 4. The plus or minus is a convenience, however, just to indicate that we do have two solutions. And by the way, let me just add on to this the fact that you remember that x squared minus 16 is factorable as a sum and difference of two squares. And if we go back to our factoring method, you might recall that this would be the same thing as saying x minus 4 times x plus 4 is equal to 0. And by setting both of those factors equal to 0 and solving for x, lo and behold, we get the same solution set over again, where x minus 4 is equal to 0 and x plus 4 is equal to 0, implies that x is equal to 4 or negative 4 as our two solutions, which is exactly what we found above here. So it sort of verifies our property using the square root. So let's do this now with a couple other examples. Let's say we've got 3x squared minus 54 is equal to 0. Well, if we're using the square root property, what we're aiming to do is we're aiming to use the idea that if we take the square x squared is equal to some number, then x is going to equal to the positive and negative of the square root of that number on the opposite side. And we can use that to our advantage right here when we take 3x squared minus 54 is equal to 0, which is to say that 3 times x squared is equal to 54. And dividing both sides by 3 gives us x squared is equal to 18. So now let's employ that square root property here. If x squared is equal to a, then x is equal to positive or negative the square root of a. So in this case, x would be equal to positive or negative the square root of 18. And you might recognize that 18 is one of those numbers that has a perfect square factor of 9. So we can reduce this a little bit further and say 9 times 2 under the root becomes x equals plus or minus 3 times the square root of 2. And we would not have gotten that answer by factoring here. So we have increased our ability to find solutions to certain kinds of equations that we might not have before. All right, let's try another one right here. This time we've got x squared plus 18 is equal to 6. So this time I'm going to subtract 18 from both sides to isolate my x squared term. I'm going to find that x squared is equal to negative 12. Well, now we've got a little bit of a different problem this time because we've got a negative on the other side, but that's okay. If we don't limit ourselves to the set of real numbers, we can say that x is equal to positive or negative the square root of negative 12. And if you recall from our definitions at the end of chapter 8, this is a complex number. It'll be of the form x is equal to positive or negative, when we simplify this, the square root of negative 1 times the square root of 4 times the square root of 3. And so in standard form of our complex number, we're going to write x is equal to positive or negative 2i, which takes the place of square root of negative 1 times the square root of 3. So in fact, we have two solutions here as well. One more set of examples in the next video.